All right, everyone, let's talk a little bit more about point counts. This is what we're going to be doing virtually. Now, for point counts, we're in a forest. This is typically something that's more recommended. You're not going to have a straight trail necessarily. So what you want to do mainly is have points that are a certain distance apart, such that in each point you're pretty confident you're independently sampling different individuals. Okay. Now, a point, it can be an unlimited distance point in which you count everything whatever you detect, you're trying to estimate the distance to every bird. Now, that's tricky, and typically what people do is they practice maybe with a rangefinder ahead of time, looking at certain distances and saying, once you get a good sense for what that distance is, when you hear a bird or see a bird around there calling, you have a good sense of the distance that you're estimating to the detection, right? So if you're here, that's you, and like you get a good sense of estimating, let's say 10 meters, because you see this tree here and you see a bird in here. So whenever you're walking around, you can try and use markers or kind of estimate what's 10 meters, what's 20 meters, and then what's 30 meters away. And past that, it starts to get pretty sketchy. So in other words, the error rate tends to increase dramatically the farther away you get. Most of us are pretty good estimating close distances. We're not so good estimating far away, but we can practice. We can practice by doing a playback of a speaker, looking at birds, hearing birds, and seeing what the distances are, okay? And that's kind of the rough idea of how people estimate the distances audially and visually. And of course, it's gonna change with the habitat, time of day, and the density of vegetation. But for us, let's say we're in one habitat, we're gonna be doing point counts. One thing to realize is that we're gonna do, let's say, a 50-meter point count. That's what we'll do in our scenario, and that means we're gonna estimate in each direction from the observer. We're gonna count everything within a 50-meter radius. Okay. And by doing that, what you're saying is that, well, if I detect bird species A, I detect one individual here. This is bird species A, and I say this is 20 meters, right? And then I detect another individual, let's say out this direction, at 40 meters. And then let's say species B, I'll detect out here also at 40 meters. This is species B. I have two individuals of species A and one individual species B. And I'll do that for all the different species. And because this is 50 meters this way and 50 meters this way, all those individuals in a unit area gives us the density of individuals within that area for all the species, right? So we're actually can get a density estimate for all the different species. That's the optimal scenario. And of course, a lot of things change that. The second thing to consider is, well, we're doing this for a standard unit amount of time. So if we were gonna do this, and that's the trade-off. The trade-off here is that you're doing at a fixed point, and let's say we're gonna count all the birds in a 10-minute time period. We start like a stopwatch or your watch, and you start counting all the birds you're detecting within 10 minutes. Well, there's a trade-off here. The longer you do the point, obviously if you do a 10-minute point versus a 5-minute point, the chances of detecting more species and more individuals goes up. But because you're staying in the same spot, the chance also happen, because birds move, that you're going to double count birds. So there's a trade-off there. Mostly the cutoff is normally around 10 to 12 minutes that I've seen people use, okay? We're gonna use 5 minutes, okay, for points. We're gonna make it really short, so we're probably not gonna get a whole lot. The second thing to consider is, with a point, what we also do is we get a degree heading. So if this is 0 degrees, let's say this is north, we get a degree heading for each bird. So remember, this is 90 degrees, this is 180, and this is 270 degrees, right? So this is west, that's east, this is north, that's south. And what this does when you do the point, let's say I have one individual, and I hear this individual, let's say let's say 120 degrees. I put that down in my notes, and then I hear this individual at 240. And I do that because that helps me, and I hear this within a relatively good amount of time, it helps me keep track of the different individuals. Because if I hear this at 1 minute, and then I hear it here, and then I hear it here, then it's probably the same individuals, I can hear it moving. But if I do this, and I hear these simultaneously, I can kind of get a sense for how many birds there are of each species, okay? And this takes practice. And now that's ultimately what you kind of want to do with a point. Once you're done with that 10 minutes, you want to move and let's say you want to make sure you go 200 meters, and then you have another point over here, right? And you do the same thing in the next 10 minutes. And that, what people tend to do is you do that, and then you move another 200 meters, and you want to make sure that each point is the same distance away, or at least a minimal distance away from another point, so that you get independent samples of the community. And ultimately, if you were to do long-term censusing, you would have these points marked in a GPS, and you could repeatedly census these through time and revisit these places, which is what people do. And what I mentioned previously, right, is you can't do a straight route. Let's say you're navigating around, like the side of a hill or something. All you have to get to do is make sure these points are independently apart, and that's one of the advantages, right? As long as they're kind of independently spaced, they can be in any configuration you want, really. And that way you're getting independent samples of the community. And so that's what you want to do. And the last thing is as you done with this point, when you walk, before you do what you want to walk as quick as you can, because 200 meters takes some time. And then when you get to your next point, you want to wait a minute or two before you start the point. You want things to settle down because things get startled, and you're trying to stay in one spot in one time, and that way not move a whole lot, and that way you can detect things without your movement affecting things. And also, by staying in one point and not walking, you can hear things better because you're not crunching, you're not hearing your backpack, so you can hear subtle sounds more. And that's one of the advantages of staying in one fixed spot, is that you're not masking the sounds of the forest and the birds by your own movements and your own equipment, because it's when you walk, you can make quite a lot of noise, crunching on gravel, crunching on leaves, etc. And that's the other thing. And so then when you're done with that, you want to make sure that you start early in the morning. Typically birds are active early in the morning, and you want to get these points done as quick as possible. You don't want to saunter between these 200 meters. You want to walk as quick as you can and get to the next point, so that you get, instead of 5 minutes between each point, you walk in maybe 2.5 minutes, because otherwise 5 minutes times 10 points, that's 50 minutes of just walking. That's the difference between 8 in the morning, finishing at 8 versus finishing at 9 in the morning. And that could be a big difference in terms of activity. And then lastly, if you revisit these points, you want to randomize the order in which you resample the points, right? You don't always want to start this point at 6 in the morning and this point at 6:30 and that next point at 7. You want to randomize the order so that you resample the points different times a day. Okay, so those are the main things we want to talk about with points, and then we're going to do a very simplified version of that for the virtual lab in class. Okay, thank you. All right, everyone, here is what one of our points would look like. We have the date, the top column, we have observer, we have the point, we have the species, the time of detection of each individual. Then we have distance and direction, okay? And distance, remember, we're always going in meters, so distance is, which to you is almost like yards, but anyway. So it's the meters, and then degrees, this direction and compass degrees. This is how we do our point. So for these first 3 columns, notice we have these arrows. That indicates that 0.5, the arrow says up to here, to this, all these are 0.5, all these are the same observer, AEM, and all these are the 14th of July, 2020. Okay. Now, the species usually have 4-letter codes. Here I started with 6 because usually I use 6-letter codes when I work in the Amazon, but so I kind of had some reflex there, but now we go down, usually 4-letter codes. The first 2 are the first, it's kind of, so in other words, if you have dark-eyed junco, DA would be the first DA, and then junco, GU, so that's Daju. NA means we have it unidentified. And then here are the times for each individual bird. So notice that, for instance, if you have, here's a dark-eyed junco, I saw one first here at 8:20, and then I saw another one at 8:22. And then you know these are 2 individuals look how far apart the distance and the time was, so I know that they're 2 separate individuals. And here's all the individuals then we get for the point. Now the thing I want you guys to realize is that we can't do distance direction, so for the virtual lab, the things you guys are going to be focusing on are, hold on a second. Are those first 4 columns that I've highlighted. Date, 5 columns. Date, observation, point, species, and time, okay? Those are the things you can't obviously do distance direction, because all I want you to do is you're going to specialize on making detections of a certain species in each point, and then you're going to write down where you first detected it, okay? And that's what you guys are going to do for the virtual lab. I'll put up online the whole instruction and then the Google Drive sheet that you will enter this data into as you hear the points, the recordings that we're taking for these points, okay? And lastly, it's 14 July, so for you history buffs, you may want to wish any of your French compadres or comadres happy independence, start of the Independence Day for France. Okay, anyway, talk to you guys later. Bye.